All right, continuing on section 3.2, we're going to learn about residual plots. So far we've only talked about scatter plots, which are the most important graph, but I guess as far as bivariate data goes, a residual plot will be the second most important plot. So let's start with an example, and this example has kind of been tailor-made to illustrate the need for a residual plot, or at least that's what I'm hoping it does. So pause the video if you want and put this into your calculator. This is fictional data about the weight of 9 different protein bars and their number of calories in each bar, the amount of energy in each. Directions say find and interpret the correlation coefficient. So let's just review, I guess. So I got my data in the calculator. Like I said, pause it if you want to follow along. Let's open up a new page. Let's look at the scatter plot. Independent and dependent, I guess weight would be the explanatory variable and energy would be the response. So let's put weight versus energy. Oops, I'm sorry, what did I do? Weight versus weight. Weight versus energy. So as you can see, there's a really strong relationship. So I guess I would ask you guys to see if you could, to describe that. Think about it before I say what it's going to be. Certainly positive, and it's very strong. The form is the thing that you're going to need to be a little bit careful about. I think most of us would look at that and say that it's linear. I mean, it looks linear. So, it actually asks us to find and interpret the correlation coefficient. So, menu, analyze, let's find the regression model. There it is. I don't really care what the equation is. I want the R value. Remember, when you run the regression model, it calculates and stores that R value in the calculator. I guess I should take this opportunity to show you the other way. You don't have to graph it. If you wanted to actually analyze it, you go to menu, statistics, stat calculations, and you could go to linear regression. I want to put my weight in as the X. I want to put my energy in as the Y. Kind of just leave the rest of these alone. And this is kind of the linear regression output, but it's kind of the same thing. It gives us the A value, the B value, the slope of the y-intercept, and it gives us the R value right there. I don't like running it like that because you should always look at the graph. So do the graph, find it, and then just, well, whatever. The R value is 0.999. So R equals 0.999. Interpret it. How do we interpret this? Well, we describe the distribution. So I'm going to say what I think you guys would probably say. There is a very strong positive linear relation. Let's start using the word association. I like that better. Sounds better. Between, or even correlation, right? Between weight and energy. Got my duffs and my context. Strong, positive, linear context. So a residual plot. A residual plot is simply a scatter plot of the residuals against the explanatory variable. Residual plots help us assess whether a linear model is appropriate. So here's some scatter plots along with their corresponding residual plots. So here's a scatter plot of goals versus in 2015 versus goals in 2016, and there's a residual plot. So remember, graphically, the residuals are these things: below, on, little above, lot below, little above, little below, lot above. So basically, this plot is this value here is that value there, almost on, little above. So this is simply a plot of all of these distances from the line. However, we don't actually graph the line, and it kind of rescales it so that we can see the residuals a little more clearly. Okay, that's it. That's all a residual plot is. Notice here a linear model is appropriate, right? And our residual plot kind of looks like this. Here, a linear model is not appropriate, and our residual plot looks like this. So as you can see, there's below, below, above, 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 below, below. So we get below, below, all of these above, and all these below. Okay? Whereas here, if the data is approximately linear, then you kind of should expect to kind of get some below and some above and some below and some above. You should expect them to kind of be scattered kind of above and below randomly. Here's another one of a crazy curved data set. Obviously, a linear model is not appropriate, and the corresponding residual plot. So, this is a residual there. This is that residual. I guess I don't even know which one it is. Probably that one right there. So how do we use these residual plots? Why are they important? Well, we use residual plots as a tool to evaluate if the form of the model is appropriate or not. If there is a leftover pattern in the residual plot, then the current model is not appropriate. I can see a pattern. This is not an appropriate model. I can see a pattern. This is not an appropriate model. There's no pattern on this one, so this is an appropriate model. Now, what you guys might be saying, or maybe even should be saying, is, well, I can see that. I can see this is linear, and I can see these are not. But what a residual plot will do is it'll kind of help us, it'll kind of, is accentuate the right word? It'll kind of highlight or give us a better picture of some slight things that you might not be able to see with the naked eye, okay? If there's no leftover pattern, then the current model is appropriate. So let's not, if there's no pattern left over in the residuals, or if the plot shows random scatter, then a linear model is appropriate. So let's revisit the protein bar example and create a linear model, create the residual plot, and see if a linear model is appropriate. So how do we make a residual plot? Well, there's a couple ways to do it. I'm going to show you the way I like first, because I like a nice big graph. So here's what I would do. I would open up a new model, a new data plot. I would put my weight on so make the same weight. However, instead of graphing energy on the x, remember, when you run the linear model, it stores your residuals into this list called stat resid. So we could just plot those residuals. That's a residual plot. Notice, okay, so that's one way to get a residual plot. That's the way I like to do it. The other way is, and this is, you might like this better, you don't have to do anything. You go to Menu, excuse me, Analyze, and if you go down to this residual option right here, it'll say Show Residuals or Show the Residual Plot. This is actually kind of interesting. Show the residual square. Let's not do that. Show Residual Plot. So what it does is it does a split window and shows you the plot up here and then the residual plot down here. So I guess if you like that, that's kind of good. Like I said, I kind of like a bigger graph because, I'm old and have bad eyesight, I guess. Okay. Is the linear model appropriate? Why or why not? So notice there's a definite pattern in this residual plot. That means that no, the residual plot, the resid plot, has a pattern. Therefore, the original scatter plot was not normal. And maybe some of you guys might have noticed that when we graphed it the first time. Let's go back to the original data set. Oh, I got that stupid. See, I don't like that. Undo. Oh, geez. Undo. Undo. All right, I don't know what I'm doing anymore. I'm just going to open up a new plot. That's why I don't like doing that stupid residual plot on the same screen. There was my original plot, and let's show that regression line again. See, you really couldn't see it because it was so subtle, but these points are below. You can kind of see more than area on below, and then above, 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 below, below. There's really slight curvature to this data set that you really can hardly see with the naked eye. But the residual plot makes it much easier to see. So that's kind of the power of the residual plot, and that's why they're kind of important. A residual plot can help us evaluate the appropriateness of a model when the naked eye may not be able to detect patterns from a scatter plot. Okay? All right. Thank you.